Hi everyone, welcome to coding tutorial 8 of neural networks and deep learning. My name is Everly. Today we're going to learn how to load a pre-trained object detection model and then inference it on an image and then visualize the results using OpenCV. Um, so both Keras and PyTorch provide a variety of um, pre-trained models in their libraries. And today for object detection, we're going to run a faster RCNN model in PyTorch. For visualization, today we're going to practice with object detection, the bounding boxes, visualizing the boxes to generate qualitative results. So OpenCV is an open source computer vision and also machine learning library. It provides comprehensive tools and functions for both image and video processing, and it can be pretty helpful in terms of processing image data and also generating some qualitative results with the desired visualization and so on. So today we're just going to practice a couple of the basic drawing functions, but you can always visit their documentation to see what is available. For example, with image processing, they have many different tools here, like geometric transformation and thresholding images, smoothing, and so on. So if you're looking for some computer vision algorithms, you can check if OpenCV have them. So let's first start with data processing. Don't forget to mount your drive before you start. And for today's data, I provide a zip file in this link. And if you just unzip that file, you will see three images in the folder and also a JSON file that we're going to make use of later. All right, so let's start. These are the three images with the image names. So you can just copy this, and for inferencing, I encourage you to try any other images that you can get. So these three are just three random images that I got from Cocoa dataset. So for today's pre-trained model, it's pre-trained on Cocoa dataset. So we're going to load the categories in there, and you can try feeding the model other images not from Cocoa to see how well the model does on those examples as well. All right, so let's start with reading the image. And since today we're practicing how to use OpenCV, we're no longer using Pillow to load the image. So here, let's first import CV2, that is for OpenCV. And for reading an image, you can check out the documentation here. It's pretty simple. You can just use cv2.imread and then put the path to the file over here, and it should output an image, which is and the array. So for this array, we can print the shape. I'm going to run the cell. All right, so the first dimension here is the width of the image, and the second is the height, and then three color channels. So this is a basic, just the array of an image. And now we're going to process this just as we did for Keras before, But for torch, the dimensionality is a little bit different. So the first dimension here is still batch size, but the second dimension is the channel, the color channels, and the third is height. The third is height, and the fourth is width. So with that, let's first import torch and also import um, torch vision, and they have transforms. And with that, we can transform data into tensor as required from torch. So let's create an object for transform to tensor. So with that, we'll be able to use this as a function, um, tensor, and then when we call transform, we can throw in an image, which is the image we just read. So for the color channel, sometimes the settings in the packages can be a little bit different. For example, usually for Torch, the default would be RGB. R meaning red, G is green, and B is blue. And uh, OpenCV usually is in BGR manner, and PyPlot, as we have used many times before, it is usually in RGB manner. Uh, these are just the facts about the packages. And with that, we will notice that since there's a gap between CV2 and Torch, we will need to do a simple color channel convert. So we can call CV2 convert color and then input this image. And for the second argument, we can assign the color with from BGR to RGB. This one. All right. So now we throw in to transform an image that's an RGB image. The array, we got this tensor. So let's print the tensor shape. Um, so the tensor shape now is 3 by 4 is 27 and 640, and we are going to add this batch. So since we're just inferencing on one image, it's pretty similar to what we did before. Let's name it image tensor, and then just simply use this tensor and assign a new dimension here, and then everything the same. And let's again print the shape. All right, so this is the input shape required here. And with this, we can move on to loading the model. So let's take a look at the PyTorch documentation and see what this model is. So this is a faster RCNN model, and there's a lot information here. For example, when you're training the model, what should the data look like? When you're inferencing on a model, what is the output looks like? And here's an example of how training and inferencing should be done. And we're not going to exhaust the resource here today. So we're not training on a model, and this model has been trained on COCO dataset. So basically, it should do pretty well on the COCO categories. But you can always try training the dataset or um, fine tune it on other datasets. And we're going to run inferencing here today. And for the input, it should be here. So as we established before, this is the input dimension, and don't mix that up or it's going to be a disaster. And for inferencing, let's take a look. So we know that the output of object detection should be bounding boxes, and usually the boxes should be presented in four integers manner. And here it says that the boxes are in x1, y1, x2, y2, and that indicates the the position of the bounding box. And sometimes it can be x1, y1, and then width and height. So just to make sure that you don't mix up the output, you should always check this kind of documentation before diving into calling the model and everything else. And also there's labels, and these are integers. So basically, it's going to be the predicted labels uh, in the category ID, and there's come the score. All right, now we've learned enough about this available model. Let's start coding. All right, so first of all, let's import this. So that's Forge Vision and models. So most of the pre-trained models are in here, and this one is in detection. And then let's import faster RCNN plus net 50. That's the backbone. FP in. Oh, all right. So now we have this model. It's very simple to load this model. We can just call this and then pre-trained is true. And in here, it also talks all about the default pre-trained model that you can learn from how they train the weights and everything. So that's the first step. And then for PyTorch, when we are inferencing a model, we need to set it to an evaluation mode. So set model to evaluation, that is model dot eval. All right. So this is all we do to prepare the model for evaluation. And then we also need the model not to have gradient because we're inferencing. So perform inference, we should do no gradient. And then with that, prediction will be, let's call the model, and then our data over here, image tensor. And now, okay, so now we should have the prediction result in here, this object, and we can unpack it. So for the boxes, remember as we saw here for the inferencing. These are the results. So let's do the boxes first. Prediction and boxes. So this should give us a tensor of the boxes results. And then usually to further utilize it, we can use NumPy array to replace that tensor. And to do that, this is how we transform that. So just call CPU and then NumPy, and now it's NumPy array. So let's do the same thing for these two results labels. Um, these labels are IDs, so let's just make that clear. And the final one is scores. So, and now this should help us unpack the information we need for this first image and the only image. All right, so with that, we have all the predictions. Now let's try visualizing the results. So again, if we need to visualize it in the script, import matplotlib pyplot splt. All right, so let's write a visualization function here. Visualize the bounding box output from object detection model. So first, let's have the image, and then all this information over here. So the boxes, the labels, and scores. And with that, we can start with copying the image over. So let's not change anything in this original image. So we can have a new image here for visualization. And just to copy the image over. So before we proceed, let's go back to here. So if we are to visualize this results, Matplotlib is in RGB manner. So again, for the original image read from CV2, we are going to convert it. So let's do CV2 convert color and then the image itself. And again, this will be BGR to RGB. All right, so that's the image. And we know that the results are going to be in bounding boxes, so label IDs, scores, and everything. So we can try to print that out to see what it should be. Okay, so basically it's an array. The boxes is an array of four numbers together. And okay, sorry, these are not integers. These are float, that's the prediction. And so for these numbers, we are going to visualize it and pair it with the corresponding label IDs and scores. So the label IDs are going to be here. So that's the category ID. And then scores should be float of the confidence level. of all these boxes, and it's also sorted from the highest to the lowest. Okay, so with that, let's use a for loop to draw all this information. So label and score, and that would be in zip of boxes, labels, and scores. And in this loop, we need to first unpack x, y, well, x1, y1, x2, and y2 as stated in the documentation, and that's from the box. And then um, we can visualize it. So for this image, we can call CV2 rectangle. All right, so CV2 rectangle helps us draw a rectangle um, over in an image. And so the first argument is the input image, and the second would be x1, x2 point, and the third is, sorry, x1, y1 point, and then the third would be x2, y2 point, and then the color, and then the thickness. So you can go here to check out the detailed information. That's basically what we've just established. So with that, we will input the same image, and then with x1, y1, x2, and y2. And so we've seen that these are float numbers. So for drawing, we need to change them into integers. Okay, so with that, let's have a color here. So the color now is RGB. So if we do 255, 0 and 0, that would be a red box drawn. And then just thickness. Okay, so this is the box. And now let's plot the image. So this is our visualization function. And to visualize it, we can just do visual uh, visualize bounding box, and then input the set of information. So that is the box, the boxes, labels, and scores. And let's see, label IDs. Let's see what happens. Uh-huh. Oh, the image. Excuse me. So this image should be, we can trace it back to originally reading using CV2. So rectangle. All right. So this is the course visualization that we see here. So as you might have noticed, the confidence score, some of the confidence scores are low. So usually for this this kind of object detection models, we can do a threshold here. Let's say confidence greater than 0.8. And then for all these bounding boxes, let's only do if the score is greater than or equal to the threshold. Then we visualize it. Okay, so now let's rerun this. All right, there is much fewer bounding boxes available here. So these are the objects detected that have enough confidence score. You can change the threshold on your own. And so with that, we haven't visualized the labels. So let's take a look at put text. And this is the function for input text and with the location and font, color, and thickness. So let's do first the text should be um, let's first put label there and then the confidence score. So and then for image viz do cv2 put text and then the same image and then the text we desire to display and again x and y and do a little offset here. Then the font can be Hershey and then that's the size and again use the color red and finally thickness. All right, let's run this again. Um, okay, so now we see that the displayed image has the label ID and the confidence score. Now, um, for this PyTorch output, it only has the ID of the labels. So I provide these Cocoa categories over here in the JSON file. We can practice quickly how to import, um, how to load data from JSON because it is also a very commonly used package and a data type. So let's import JSON and then very similar to Pickle, we can use with open and then from this same directory, we have Cocoa categories. And then for reading the file, use R. This is our data and call JSON load. And with that, we should have the data loaded. So in this data, you should be able to acquire the categories under within this dictionary called the category, and you can find a list of categories, and it has the ID and the name. So we can simply assign a dictionary to map the category ID to name. So let's call it Coco Cat ID2 name, and that's a dictionary. So use this category ID to name. And all right, so now we have this dictionary, and we can make use of this to help us um, generate the bounding boxes with the category names on them. So for all these label IDs, let's do label names, and this would be from this dictionary, find label ID, and for label ID in label IDs. And with these names, we can input it to visualization. So there, let's run this again. Okay, there's an error. Uh, so, oh, I forgot to, yeah, that's what I was saying earlier. So this is a dictionary, and all the categories are stored under categories. Let's rerun this. And now we have all the names of the objects on top of the boxes. So that is all for generating a simple quantitative result for object detection bounding boxes. And a final note, if you'd like to save the image, you can use CV2 image write, and then assign the directory, and let's say viz.png, and then for the second argument, the image. And with this, you can save the oh, you can save your image. And there. Okay, so after running this, if I go to the directory, I'll be able to see this image. And I forgot to change it back to um, BGR. So yeah, so this is CV2, and for visualization, again, we're going to convert the colors. So a quick review of today's tutorial. We loaded a pre-trained model from PyTorch, and the preprocessing steps for image data is a little bit different from Keras in PyTorch. And we learned to inference on an image. And then finally, we visualize the bounding boxes generated by the object detection model using CV2 package, and we save the image. So that's all for today's tutorial. If you have any questions, you're welcome to stop by my office hours or leave your questions on Piazza. See you next time.